form bond with the third fluorine atoms having one unpaired electron and formation of the BF3 molecules. BF3 molecules. How the structure will form? How they are oriented in the orbitals? See, this is the boron atom having the three hybrid orbitals. One orbital is the this is the sp2, sp2, sp2. This is the hybrid orbital having one unpaired electron. This is the one unpaired electron. See, this is the one unpaired electron, and also one unpaired electron. This is the hybrid sp2 orbitals having three unpaired electrons, and we have three fluorine atoms attached to the boron atom. How they will bond? How orbitals are overlap? Here, fluorine atoms having these orbitals. Fluorine atoms these fluorine atoms having orbitals, and also fluorine atoms one unpaired electron. This orbital, this electron from the boron atom and one electron from the fluorine atom. These two orbitals are intermixed and formation overlapping. These two hybrid orbitals are overlapping and formation of the new. This is the new sigma bond. This is the sigma bond. Formation of new sigma bond. And same for the another two orbitals. Here also fluorine atoms having unpaired electrons, one unpaired electron, and boron one unpaired electron will form a bond. Then also here for fluorine atoms, this, and this is the orientation of BF3 molecules. In these two orbitals having 120 angle. These two orbitals having 120 angle. And their geometry is, we saw their geometry is trigonal planar. Trigonal. This is the geometry is the trigonal planar having 120 bond angle between these two orbitals. And their hybridization is sp2. Hybridization is sp2. This is the detailed explanation of the BF3 molecules. We determine the shape, geometry, also hybridization, also their bond angle also. We saw their structure of the BF3 molecules, how they are actual orientation of the orbitals. Now we start next hybridization third types of hybridization. Third types of hybridization. Third types of hybridization. Type number 3. In third type, you take the s orbital, one orbital and another three orbitals, 1, 2, and 3. 1, 2, and 3. Now, this is the p orbitals, and this is the s orbital. These two orbitals, how many orbitals share atomic orbitals? 1s and 3 p orbitals are intermixing, and formation of newly formed hybrid orbitals. How many hybrid orbitals will form? 4 hybrid orbitals will form. Here to take the now form the 4 hybrid orbitals. 1, 2, 3, and 4. 4 orbitals form. Okay, now this name is the sp3, 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 sp3 hybrid orbitals. This is the sp3 hybridization. This is the sp3 hybridized types. sp3 hybridization having their geometry is tetrahedral geometry and tetrahedral geometry. See, now we will see the orientation of the tetrahedral geometry. Orientation of this sp3 hybridized orbital. sp3 hybridized orbital. See, is the center is the one above the plane. Third one is this side. In sp3 hybridization, in tetrahedral geometry, one element is above the plane. Next 3 orbitals, one is back to this plane. Suppose we have one plane. Yeah, we have one plane. This orbital is above the plane. This orbital is backside. Orbitals back. This orbital is backside, and these 2 orbitals are front orbitals. This is the geometry of the sp3 hybridized orbital. This is the orientation of the sp3 hybridization. Now we take the example. We take the example SiCl4. This is the Si. This is the silicon, and Cl is the chlorine atoms. Silicon. Now start with silicon. Silicon atomic number is 14, and their electronic configuration is 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, and 3p2. Yeah. See, this is the 6 and 10, 14. Okay. This is the electronic configuration of the silicon. And now we'll consider the last valence electron cell. This is the last valence electron. This is the valence cell. Here in 3s orbitals having 2 paired electrons. Also in p orbitals, here in p orbitals having only 2 unpaired electrons. This is the 3p2 orbitals. This is the 3p2 orbitals, and this is the 3s2 orbitals. Now, but silicon requires the 4 unpaired electrons. Why 4? Because we have around the silicon there is the 4 chlorine atoms. For 4 chlorine atoms, silicon must have the 4 unpaired electrons. So here, see, here only 2 unpaired electrons. Now we have to form the 4 unpaired electrons by excitation of 1 electron. Excitation of 1 electron. Suppose we excite the 1 electron from 3s orbital to this 3p empty 1 orbitals. They excite 1 electron from 3s to 1 3p orbital. This is also empty p orbitals. And formation of the 4 unpaired electron. This orbital is having only 1 electron, because 1 electron jumps from 3s orbital to 3p orbital. 3p orbitals. And now in p orbitals contains 1, 2, and 3. The third electrons came from his 3s to his s orbitals, and this is the 3p. This is the 3p orbitals. 3p3 orbitals. This is the 3p orbitals. Now we have the 3 unpaired electrons. Sorry, we have the 4 unpaired electrons. This unpaired electron will form with the 4 chlorine atoms. For the bond formation, the silicon must have the silicon contains the 4 unpaired electron. Here is the 4 unpaired electron. Now also chlorine atom also must have the 1 unpaired electron for the bond formation with the silicon atoms. This is the orbitals of this is the 4 unpaired electron and orbitals of the silicon atoms. Now we'll see the chlorine atoms, their electronic configuration and their orbitals. You see here chlorine atoms. Here are the 4 chlorine atoms here. 4 chlorine atoms. Atomic number of chlorine is 17. Atomic number of chlorine is 17. Their electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. This is the electronic configuration of each chlorine atom. Each chlorine atom. This is the electronic configuration of each chlorine atom. Now we consider only these 3p orbitals. 3p5 orbitals. Only consider the p orbitals here. 1, 2, 3, 4, and 5. Having one unpaired electrons. These unpaired electrons will form with the silicon atom. This is the 1 chlorine atom orbitals. Another is for 1. Next is the same orbital orientation here. The same orbitals electron. 1, 3, 4, and this is the 5. And for each chlorine atoms having the same orbitals or electron orientation here. Now we are making the bond with the silicon. See here we have the 4 unpaired electrons of silicon, and each chlorine atoms having 1 unpaired electron. Now both atoms will make the bond between them by overlapping the orbitals. Overlapping the atomic orbitals. Okay. Now Just now we see the orientation of the silicon tetrachloride. Silicon tetrachloride. See here, silicon atoms having the these orbitals, this, and another is orbitals. Here, this chlorine also one orbitals. This chlorine atom one orbitals. Thus one orbitals. This chlorine atoms also one orbital. This is this electron one from the chlorine, one electron from silicon, one electron from chlorine, one electron from silicon, one atom from chlorine, one electron from the silicon. This is the final orientation of the tetrahedral molecules. Tetrahedral molecules. Here is the bond between the. This is the sp3 hybridization and tetrahedral their geometry. Tetrahedral. And bond angle between this orbital is 109 degrees Celsius. This is the silicon tetrachloride orbitals orientation. So, thank you.
This lecture is open for discussion. If there is any doubt, any question, you please ask.
Nothing. So first of all, so apologize for the disturbances of that slide or for the particular this setting. So thank you for the sir Arif Patan sir for the giving chance me to delivering the lecture today. Thank you, sir. Okay.
Thank you. Arif sir, may I audible?
Yes.
Hello.
So, on behalf of organizing committee,
Hello.
Gaikwad sir, Milind Gaikwad sir, and myself, I am thankful to both the principals, Dr. Mazhar Ahmad Farooqi, Principal Maulana Azad College, as well as Principal Kakade sir, for their guidance and support for organizing this lecture series. And I am also thankful to today's resource person, speaker, Ms. Dr. Ashok Bhosle, who has given a nice lecture on the topic chemical bonding and molecular structure. So on behalf of the organizing committee, we are thankful to him. We are also thankful to the students who has participated this webinar online on the Zoom platform. This video is also available on our YouTube. Thank you, one and all. Thank you.
Thank you, Arif sir.